All right, welcome to the explainer. So, look, we all think we have a pretty good handle on cause and effect, right? You flip a switch, a light comes on. It's simple. But what happens when that switch is actually one of 1,000 different things and the light is something as massive as the global climate? Yeah, that jump from simple to super complex, that's exactly what we're going to dive into.
I mean, on one hand, you've got this. You pull a string, a little toy car moves. The cause is totally clear, the effect is immediate. You see it happen. But then, on the other hand, you have these gigantic systems, like our planet's climate. It's this incredibly complex dance of countless variables, where figuring out what's really causing what is, well, one of the biggest challenges in all of science. And this really gets us to our first big idea. As the systems we try to understand get bigger and the number of moving parts just explodes, our simple, intuitive grasp of causality, it just starts to fall apart. Things get really messy really fast.
Which, of course, leads us right to the central problem for basically any scientist or engineer. How in the world do you separate a genuine cause from something that just happens to be related, but correlation? It all really boils down to this one fundamental question.
This is it. This is the big one. Imagine you're trying to figure out what triggers a stock market crash. Is it one specific event? Or is it maybe 5 different things all happening at the exact same time? And the bigger question is, how can you ever be sure? So ultimately, we're wrestling with this storm of variables all interacting with each other. That classic trap of correlation versus causation, and just a ton of background noise in the data that can completely throw you off. To try and find your way through this, scientists often turn to the mathematical world of information theory, which is all about quantifying information, to find that signal hidden in all the noise.
But what if there was a way to shine an even brighter light into that storm? Well, it turns out, now there might be. A group of researchers has developed a brand new mathematical tool that's designed to do exactly that.
A team from Caltech and MIT has created this incredibly powerful new method that kind of acts like a special lens, letting us see the really intricate web of cause and effect with a new kind of clarity, even in the most ridiculously complex systems. It's called SURD. That stands for Synergistic, Unique, Redundant Decomposition. And honestly, that last word, decomposition, that is the absolute key. See, SURD doesn't just give you a simple yes or no answer. It literally breaks the entire causal relationship down into its fundamental building blocks. And this is where it gets really cool. It turns out SURD shows us that causality isn't just one single thing. Nope, it actually comes in different flavors. Let's take a look at the 3 main types it can identify. Okay, first up, we've got what's called redundant causality. This happens when you have multiple potential causes for a single effect. Think of it like having a bunch of different keys that can all unlock the same door. You don't need every single one of them, just one will do the trick.
Here's a great example. A student might get an A on a test because they're just naturally smart, or because they studied like crazy for weeks. Both of those paths lead to the very same outcome, the good grade, which means the causes are redundant. Either one is enough all on its own.
Next, we have synergistic causality. And this is the complete opposite of what we just talked about. Here, you have multiple factors that absolutely have to team up. By themselves, they don't do anything. But together, that's when they create the effect. This is that the whole is greater than the sum of its parts idea. The medical analogy for this is just perfect. So a patient takes medicine A, but nothing happens. They try medicine B, and still no improvement. But then, when they take both medicine A and medicine B together, they make a full recovery. That right there is synergy in action. As one of the researchers, Adrien Duran, puts it, other methods might just tell you that one variable or another is a cause. But what makes SURD so special is that it captures the complete picture, the individual causes, the redundant ones, and those synergistic ones, all at the same time.
Okay, so this all sounds fantastic in theory, right? But what does it actually mean for solving real-world problems? Let's take a look at where a new tool like this can actually be used.
The applications are just huge. I mean, imagine being able to pinpoint the exact combination of factors that triggers a market crash, or identifying the synergistic risks that lead to heart failure. We could design safer aircraft by truly understanding what causes drag, or figure out precisely why some new high-tech material cracks under pressure. So to see how it works, the research team actually applied SURD to a classic, tough engineering problem, understanding turbulence when air flows over a surface, like an airplane wing. Now, for years, there have been these competing theories. Is it the slower air right near the surface that dictates what the faster air above it does? Or is it the other way around? Which flow is really the main cause of the turbulent patterns that we see? So the team took all the data from both of those airflows and fed it into the third framework to see if they could finally settle the debate. And the answer they got back was incredibly clear. So the analysis gave them two huge findings. First, it confirmed that the primary cause really does come from that faster airflow, far away from the surface. But, and this is the cool part, it didn't stop there. It also uncovered a hidden synergistic effect. The two layers were interacting to create this additional combined cause of turbulence that you would have totally missed if you only looked at them one at a time. This is just so much more than a new equation, you know? It's a fundamentally new way to ask questions about the world around us. It gives us a brand new toolkit to start dissecting some of the most tangled, complex problems we face.
What this all really means is that we now have a tool to see not just if something is a cause, but how it's a cause. Is it acting alone? Is it acting as a backup? Or is it part of a team? And that leaves us with one final, pretty exciting question to think about.